Chapter 1.6, Absolute Value Equations and Inequalities. Because of the nature of absolute value, when you solve absolute value equations, you have to take what's inside the absolute value and set it equal to the positive 5 and the negative 5. So you're going to rewrite it twice. You're going to take what's inside absolute value and set it equal to positive 5 and take it and set it equal to negative 5. You solve both equations. So you're going to add 1, get 2x equals 6, divide both sides by 2, so x is 3. Then you're going to add 1, same thing all over again, except the right hand side is going to look different. So 2x equals negative 4, divide both sides by 2, so x equals negative 2. It says to graph the solution, so you need to draw your number line. And I'm just going to do negative 2, negative 1, 0, 1, 2, and 3. Because I just need negative 2 and 3. And that's my solution. Guided practice number 1, you're going to take what's inside the absolute value, set it equal to positive 4, and set it equal to negative 4. Solve both equations. Subtract 2 and you get 3x equals 2. Divide both sides by 3. So first equation you get x equals 2/3. Still for the second equation you do the exact same thing. And I get 3x equals negative 6. Divide both sides by 3 and you get x equals negative 2. So my solution set is 2/3 and negative 2. Okay, when you have a multi-step equation, meaning I have more than just the absolute value, you have to get the absolute value by itself. So we're going to first add 1, and we get 3 times the absolute value of x plus 2 equals 9. Then divide both sides by 3. So we get the absolute value of x plus 2 equals 3. Now we're going to take it and we're going to separate it, just like we did before. Take what's inside the absolute value and set it equal to positive 3. Then set it equal to negative 3. Subtract 2. So x equals 1, subtract 2, so x equals negative 5. It does say to graph, so you're going to put a point on negative 5 and 1, and that's your graph. Your solution set may look like this, negative 5 and 1. Not an ordered pair, but a solution set. So guided practice number 2. Give myself some more room. I'm going to get absolute value by itself first. So I'm going to kind of underline that so you can see what you have to move. First we need to subtract the 3. So we get 2 times absolute value of x plus 9 equals 4. Now we need to divide both sides by 2. So the absolute value of x plus 9 equals 2. Now we separate. X plus 9 equals positive 2. X plus 9 equals negative 2. Subtract 9 from both sides. You get negative 7. Subtract 9 from both sides. You get negative 11. Your solution set is going to be negative 11, negative 7, and if you graphed it, negative 10, negative 9, negative 8, negative 7. You would just put a point on negative 11 and a point on negative 7. Now I'm going to throw you a curveball because you don't always the solutions you get are not always going to work. So, for instance, example 3, you have to get absolute value by itself first, and it's already by itself. So now you're going to take what's inside the absolute value, and you're going to set it equal to positive 4x plus 5, and you're going to set it equal to negative 4x plus 5. Don't forget that you have to distribute the negative across it. So I put the negative outside the parentheses, and we'll distribute it when we start solving. On the left equation, you are going to get the variables together. So I'm going to subtract 4x, and I get negative 1x plus 2 equals 5. Subtract 2, and I get negative 1x equals 3. Divide both sides by negative 1, so x equals negative 3. On the right-hand equation, we're going to distribute that negative, and we get 3x plus 2 equals negative 4x minus 5. Add 4x to get the variables together. Subtract 2. And then divide both sides by 7. So x equals negative 1. If it tells you to check for extraneous solutions, we did the whole problem right, but that extraneous solution is an answer that doesn't work even if you do it right. So we have to check. So we're going to plug them back in. First, we're going to plug in negative 3. Absolute value of 3. Oops. Times negative 3 plus 2 equals 4 times negative 3 plus 5. Well, I get the absolute value of 9 plus 2 equals negative 12 plus 5. Which is the absolute value of negative 7 equals negative 7. That's not true. The absolute value of negative 7 is positive 7. So this answer doesn't work. You can plug in negative 1, but it will work. So my solution is going to be x equals negative 1. Sometimes they're both extraneous, but I'm just telling you right now that that one does work. All right, guided practice number 3. We're going to solve that. Give myself some more room. And that's going to be take what's inside the absolute value, set it equal to positive 7x plus 14. Then take it and set it equal to negative 7x plus 14. And then we solve it. So we want to take the 7x and move it to the left by subtracting. And we get negative 2x minus 2 equals 14. Add 2 to both sides. So negative 2x equals 16. Divide both sides by negative 2. And you get negative 8. The second equation, we are going to first distribute the negative, and we get 5x squared, or 5x minus 2 equals negative 7x minus 14. Add the 7x to both sides to get the variables together, and we get 12x minus 2 equals negative 14. Add 2 to both sides to get the variable by itself, negative 12. Then divide both sides by 12. Okay, one of those is not going to work, so you check them. First, I'll just always plug in the left one. So we'll just do 5 times negative 8 minus 2 equals 7 times negative 8 plus 14. Well, I get negative 40 minus 2 equals negative 35 plus 14. Oh, that's silly. Look what I did. Okay, no, I'm plugging in negative 8, not negative 5. That should be negative 8, so this should be negative 56 plus 14. So negative 40 minus 2 is negative 42. Negative 56 plus 14 is negative 42. But the absolute value of negative 42 does not equal negative 42, so this one's not right, and this is my final answer. Example 4, absolute value inequalities. less than is and. I know none of that makes sense right now, but it'll help you remember. I have my little inequality. You still have to get absolute value by itself, and it already is. When you have less than, you're going to make that an and inequality. So you're going to do 2x minus 1 less than 5, and then when you change the 5 here to a negative, like you've been doing, you have to turn your inequality around. So we're going to do 2x minus 1 greater than negative 5. Now we just solve it. So we add 1, and we get 2x less than 6. Divide both sides by 2, so x is less than 3. On the right hand side, add 1, so we get 2x greater than negative 4. Divide both sides by positive 2, so I leave my inequality alone, and I get greater than negative 2. Since it's an and, you put your variable in the middle, the smaller number on the left, the bigger number on the right, and you put your inequality symbols in there as they go. So the x is greater than negative 2, so I'm going to put my inequality in that way. And then the x is less than 3, so I'm going to put my inequality in that way. And that's my answer. It does say to graph the solution, so when you graph it on a number line, you're going to put the lower number on the left, the bigger number on the right. They both get open circles, and you shade between. Guided practice number 4. We are going to, now if at any point you feel like you can do it yourself, then pause the video and try it on your own. But I just am going to go through all of them. So just don't wait on me to make you pause it. Alright, I have less than or equal to, so that's still going to be an and inequality. And I get 3x minus 4 is less than or equal to 8. 3x minus 4 is greater than or equal to negative 8. Now we're going to add 4, and we get 3x is less than or equal to 12. Divide by positive 3, so my inequality stays the same, and we get 4. On the right hand side, we're going to add 4, and we get 3x is greater than or equal to negative 4. Divide both sides by 3, so x is greater than or equal to negative 4/3. That's negative 1 1/3. If anybody likes the improper fractions. So when we do our number line, we're going to go negative 1, negative 2, because we have to do the 1 1/3. Alright, this is an and. So my lower number is going to go on the left. Less than or equal to x less than or equal to 4. That's my inequality. Negative 4/3 is negative 1 1/3. We're going to go left to a negative 1 and then about a third more. And it's a closed circle because it's included. 4 is going to also get a closed circle because it's included, and it's an and, so we shade in between. Okay, now if I have greater than, that's going to be an or inequality. So we're still going to take what's inside the inequality. We're going to set it greater than or equal to positive 6, or take it and set it less than or equal to negative 6. When you do the negative, you have to turn your inequality around. Now you just solve the two inequalities. So subtract 4, and we get 2x is greater than or equal to 2. Divide both sides by 2, and you get x is greater than or equal to 1. Again, subtract 4, and you get 2x is less than or equal to 10, negative. Divide both sides by 2, and you get x is less than or equal to negative 5. If I'm moving too fast, you have control of the pause button, so pause the video. Put it in your inequality. It's an or, so you just put the smaller number on the left, less than or equal to negative 5, or x is greater than or equal to 1, and that's your answer. And when they tell you to put it on a number line, you're going to put the lower number on the left, the bigger number on the right, and you can put all the numbers in the middle, but for time's sake, I'm going to not. We put a closed circle because it's greater than or equal to, and shade all the numbers greater than 1. And then it's less than or equal to, so we're going to shade all the numbers less than negative 5. Since it's or, we're shading on the outside. That's not always true, but it's a good rule. Okay, guided practice 5, we've got greater than, that means or, and I like to say great or than to help me remember. Greater than. So we're going to do 5x plus 10 greater than 15, or 5x plus 10 less than negative 15, because you have to turn it around when you do the negative, and then subtract 10. So 5x is greater than 5, so x must be greater than 1. Subtract 10. 5x is less than negative 25. X must be less than negative 5. So your answer is going to be x is less than negative 5 or x is greater than 1. Your number line is going to have negative 5 on the left with an open circle, and it's going to have 1 on the right with an open circle. And you still shade on the outside. Those answers are a lot like the ones I just had. Okay, I want you to pause the video here, do these 3 questions, show all of your work. You have to attempt every question. You have to give me an answer to every question. Writing down the question does not count, and please do not cheat because I can tell.